How exciting! So it is very exciting. SpaceX just recently had their static fire of the Falcon Heavy rocket. All 27 Merlin 1D engines roaring to life. Just listen to that sound. This machine, putting out more than 5 million pounds of thrust, is going to put twice the payload of the shuttle into orbit and will be the most powerful rocket in current operation. Let's explore what makes SpaceX and the Falcon Heavy rocket so important for the future of space travel. As we speak, Falcon Heavy sits on pad 39A at Kennedy Space Center in Florida with its special cargo, Elon Musk's personal cherry red Tesla Roadster. If all goes to plan, the Roadster, playing the song Space Oddity, is headed for an orbit around the Sun to mimic Mars, where it will hopefully stay for millions of years. Maybe for someone else to find. Recently, the Falcon 9 rocket has been wildly successful for both SpaceX and the US government, with a projected 10 to 15 launches per year. So the next logical step is to build a larger rocket for proving future technological advancements in rocket design to get us to the rusty planet. Although formally announced in Q4 of 2011, the program has been delayed on a number of occasions. Musk is known for setting ambitious deadlines to pressure his workforce to do the impossible. But the fact of the matter is that the Falcon 9 technology was hardly mature enough to begin work on the Falcon Heavy rocket. The latest iteration, the Falcon 9 Full Thrust, or version 1.2, was not perfected until 2016. The Falcon 9 has achieved reliable reusability, and its Merlin 1D and 1D vac engines are putting out 50% more thrust than before. So how does SpaceX keep costs so low? Well, we've seen with Tesla and the Gigafactory, Elon Musk is a revolutionary when considering the reduction in manufacturing and operating costs. He is able to bring products to market at extremely reasonable prices. In fact, SpaceX publishes the open and fixed launch costs of their different launch services, the only space company to do so. Although it's changed somewhat over the years, currently the Falcon Heavy can put 63,800 kilograms, or 140,660 Freedom units, into space for $90 million. That's an astonishing $1,400 per kilogram, or $640 per pound of payload. It will be the first launch vehicle to put 1 pound of payload into orbit for less than $1,000. To compare, the current champion for max low Earth orbit payload is the United Launch Alliance's Delta IV Heavy. This vehicle can put 63,470 pounds into orbit for roughly $400 million, or $6,300 per pound of payload. So the Falcon Heavy rocket can put more than twice the payload of the Delta IV Heavy into a similar orbit for roughly a quarter of the cost. Many factors allow for such an improvement in payload price tags, but there are two main reasons as I see it. One is SpaceX's relatively low manufacturing costs. In fact, 70% of each Falcon 9 rocket is made at SpaceX HQ in Hawthorne, California. This helps to alleviate product markup, dependency, and schedule conflicts from third-party suppliers. Since the rocket boosters are not mass-produced, economies of scale are irrelevant. Taking this one step further, the Falcon 9 is identical regardless of mission. In fact, the second stage tanks are a scaled version of the first stage tanks, so tooling, material, and manufacturing techniques are limited in scope. Finally, the Falcon Heavy is composed of one structurally reinforced Falcon 9 full thrust core and two Falcon 9 full thrust rockets acting as liquid fuel boosters. Number two is low operating costs, which is the result of reusability. As many of you know, the Falcon 9 first stages are capable of reflight, the first orbital class rocket to achieve this. It's even been stipulated that SpaceX is working on retrieving other integral parts as well, such as the fairing. But what this all boils down to is cost savings. Since the first stages can be recaptured and are not expendable, a part of the $27.5 million price tag can be recovered. With the life of one stage proposed to be around 15 launches, the savings add up, even after we calculate the refurbishment costs. So what does this mean? It means that with an ever-shrinking NASA budget, we will be able to put more mass into space at a cheaper cost. This, alongside the increased payload capacity of the Falcon Heavy, will put people back into space via the Dragon capsule and possibly back onto the moon. In addition, we will see larger government and commercial cargo operations and a complete financial overhaul of space transport. Let's hope for the best as we look forward to the Falcon Heavy launch in the coming weeks. Even Elon Musk has said that if it clears the tower, it would be considered a success. But I'd be willing to bet that the rocket makes it to at least the stratosphere, but I'm hoping for a solar orbit. Thanks for watching, and if you learned something, consider subscribing and hitting the notification bell to be notified of upcoming content. Till next time, stay curious.